Hi student, welcome back to video lecture note for chapter 7 linear momentum. You have learned about momentum and impulse. Now let us continue for 7.2 conservation of momentum. Let's start with conservation of momentum. As I mentioned in the previous chapter, at the end of the subtopics, students capable to explain the conservation of momentum in one-dimensional collisions. So, what is the conservation of momentum? In physics, the term conservation refers to the something which does not change. This means that the variable in an equation which represent a conserved quantity in constant over the times. It has the same value before and after collisions. So in an examples, when in conservation of momentum, in the absence of the external force, it means that in the isolated system, the linear momentum of the system remain unchanged. It means that the moment, if we calculate the momentum before collision for both objects, it will remain until after collisions. Since momentum is a vector quantity, then the total linear momentum of each component must also be constant. So, the total momentum in the x-axis, y-axis or z-axis in the linear must be constant or unchanged. Conservation of momentum. So, what is the conservation of momentum? The total momentum initial collision or contact must be same or constant or remains unchanged for total momentum after or final collisions. If we have an object M1 and M2, the total momentum for both must be same after collision. If the conservation of momentum happen in the sum of collision, conservation of kinetic energy. So, total kinetic energy before collision and then total kinetic energy after collision. As we know, kinetic energy equals to half mv square. So, for initial, so half mu square for object 1, half m2 u2 for object 2 akan equal to the conservation the kinetic energy after collision. So m1 v1 square half m2 v2 square. Okay students, let's do some exercise 7.2. Okay, read the question first. Okay, question number 1. A car of A of mass 600 kg moving with initial speed 40 meter per second collide with the car B with mass 8,000 kg with initial speed 20 meter per second in the same direction. So mention about same directions. Okay, if a car B move forward 30 meter per second after the impact, so what is the velocity of the car after the crash? Okay, maybe illustrate in the figure. So a car if of A with a mass equals to 6,000 kg with a initial speed 40 meter per second and then collide with a car for car B with a mass equals to 8,800 kg and the U for B 20 meter per second, and then after impact, so the car B the car B move with speed VB equals to 30 meter per second after impact. So what will happen to the car A? V of A. Okay, so you have to figure out the information given. Let's do the answer. Okay, so firstly you use the conservation of momentum. This means that the total momentum before impacts equal to the total momentum after the impacts. Okay, so the formula is MA UA plus dengan MB UB equals to MA VA plus MB VB. Okay, and then we put the VA in one side and can get the equation to find the cari VA. Okay, and the substitute. Okay, the mass for A is 600. The initial speed for car A is 40 meter per second, and then plus because same directions. For object B with mass 800 kg with speed 20 meter per second, also same, plus in same directions, minus with the momentum of object B after collision, so 800 times 30 meter per second, and then divide by mass, and then you can get the value for the value of speed of car A after impact, 26.77 meter per second. Exercise 7.2, question number 2. A 0.5 kg ball traveling at 6 meter per second collides with on the 1 kg ball moving in the opposite direction at a speed 12 meter per second. After collision, the 0.5 kg ball move backward 14 meter per second after the collision. Find the velocity of the second ball after collision. Okay, we have a two ball. Ball number 1 mass is 0.5 kg with a initial speed U1 equals to 6 meter per second minus 1, collide with the ball B, ball number 2, with a mass equals to 1 kg with an initial speed U is 12 meter per second, which is mentioned about opposite direction, -1, negative, and then after collisions, the 0.5, okay, the ball which M1 ball 0.5 kg, 0.5 kg, sorry, okay, move backward, so V object A equals to -14 m as -1, so don't forget to negative here. And then for object B, mass for object number 2, mass equals to 1 kg. So what is the speed of object B? Okay, to answer this, okay, we use the conservation of linear momentum. It means that momentum before collision equal to momentum after collision. So before collision, this is M1 U1 plus M2 U2 equals to M1 V1 plus M2 V2. Okay, so and then rearrange the formula, or you can substitute the information given. So M1 is 0.5, speed is 6 meter per second, plus M2 is 1 kg, and the initial speed of object 2 is -12 equals to M1 is 0.5 kg plus P1 is negative 14 plus M2 is 1 kg and V2 we want to find the V2, and then we put one side of V2, substitute the nilai, and then the answer is negative 2 meter per second in the opposite direction. Done.